I had been using Cursor for a couple of months now or so, and it's pretty good. I was very skeptical to start with, like most programmers are, but now that there's this kind of agentic thing where you can throw it a whole code base, it goes off and does elaborate things everywhere. Great and very productive in lots of cases, I found. But I'm not such a big code of graphical editors, in particular VS Code. I think it's been great for the community. It's a really complete editor. I just don't like it that much. And when you shared the link to Claude Code, I had a look and I was like, oh, this is a terminal tool.
Yeah.
This is a bit more something that I would like to be using. So I had to get stuck in. Yeah, it gets a bit more out of the way, I think, because it doesn't force you to use it in the way the tool is built. Like, I don't think that these are ultimately going to end up being entire bespoke environments for coding. I think we have very good coding environments, and mostly developers just want to use what they have and are familiar with.
Yeah.
It's all going to get pretty commoditized at some point and become like a normal developer extension, I would expect. So I'm happy that I can use this now in this fashion, just as a separate pane in my Tmux, where I go and ask questions and make demands of my code base, which I'm pretty fond of.
Yeah. And I guess maybe just for anybody who's not familiar with Tmux, maybe you can give us just a quick explanation of what that tool does.
Yeah, sure. There's a bit going on the screen, so I'll make a new one quickly. But the gist of it is that it's a terminal multiplexer, and you have the surrounding bits at the bottom of the window you can see, and at the top of the window, which I've told it to display to give me contextual information, like the part at the bottom, those different tabs are different tabs, unsurprisingly. But the cool thing is that you can split this up any way you want. So if you want to do something down here, you can do that. You can split it again the other way. You can run Claude over here. You can basically split everything up and jump around really quickly with your keyboard. And once you get used to it, it's really productive. It's a really good way of working. And you can also detach the whole thing from the terminal you're in and SSH into other machines, or connect back to your machine from other machines and reattach it. So you can move the whole session you have away independent of the window it's running, which is very useful in some situations as well. Anyway, if you like terminal tools and you haven't used Tmux before, I thoroughly recommend it. But so what I've been up to lately, should I explain a little bit the different ways I've been using Claude initially, or should I just jump in with this fairly interesting one,
I think that there's definitely multiple things here that you've got going on that are interesting. One, Claude Code running here, in this multiplexer is the first time I'd ever seen anybody do that. And it makes perfect sense. I don't use Tmux. I use all the tools that you've been talking about lately, or I just go into terminal and just run Claude straight. So yeah, I thought that was interesting, but definitely the ray tracer, once I learned like what it is that you're building, I thought that was fascinating too. So I'd love to hear a little bit about.
So it's the way I've got it split up here first. Initially to the Tmux point, I would say is fairly typical if you're used to coding in the terminal, apart from the Claude bit, obviously, which is new. I have a normal console over here, so I can go and run, this is a Rust project, so I can run cargo build, I can run cargo test, I can do all the kind of like interactive stuff that I would typically do in a terminal. I tend to keep one of those around. I have Claude up here, so I can ask it a little bit about the project, interact with the project. And in this case, I have not touched any of the lines of code of this at all. This has been an experiment in what can I get out just by guiding it with prompt engineering. And then over here, I have Helix, which is my terminal-based text editor of choice. This is another one of those things. If you use Vim and you like Vim, try Helix. It's really good. And it's based on Rust, which means it's also very snappy. But it's a great editor for things like Rust because it has good built-in language server support and what have you. Anyway, that's the high-level overview of the three panes we have here. Okay. And what I've done in this particular case is see how far I can push Claude with building something that's fairly complicated without ever touching the code myself. And I picked a ray tracer because it's been a habit of mine when learning new programming languages for a while now to build a basic one, because you get cool output, basically. You get pretty pictures of things, spheres, teapots and whatnot. So you feel a sense of satisfaction when you get it to work. And it's also interesting both in an algorithmic sense, like the algorithms are well known and well documented, but they're chunky enough that you have to use the programming language a little bit. And also a data structure sense. And again, there's enough complexity there that you're building something that's a bit more meaningful than a hello world or a hello world REST API or whatnot. So you get a feeling for the way the language is structured.
So you've got this baseline like project that you use every single time. Is it set of instructions for the project, or do you have code that you've like just developed over the years and you use as like the baseline? Like, how does it look?
So when I do it without the generative AI, which is the way I've done it every other time, I just try and remember how I did it last time. The main thing was you need a camera, you need some stuff that you can cast rays at, you need some model for surfaces. I remember now. And then I build out from there, up from the foundational primitives. And this is also what I've tried to do a little bit with Claude. And I had a bit of a trick here. I told it at the very beginning that whenever we have a conversation or like whenever we have an interaction, it should go and update this log.md file. And it worked for a while, but it stopped working after a while. And I wonder if that's because the context window got too full.
Huh. How large is this log?
Let's have a look. 382 lines, and there was a lot more conversation than that. A couple of times while I've been using it, I've noticed it's stopped writing to the log, and then I've reminded it again to go and reread Claude.md. And it started doing it again for a while, but it's not consistent. I ultimately feel like it's a bit of a kludge because the tool itself, the Claude CLI, could do this if it wanted, and there's an open feature request on GitHub for it.
Okay.
But you can, it's interesting because you can see what I've demanded of it. Like I set the base, I say we're going to make a ray tracer. I start giving it kind of high level overview of what I want. I want you to do it with Rust. You're going to use these libraries to do, so like the standard command line parser. This is the normal library you would use to do parallel processing, which is very useful for ray tracers because they take a very long time to run. Stuff like that. And then I got a bit further into it and said, all right, there's different sorts of ray tracers. What do you know about them? And it gives me a summary of them. And then I pick one that's reasonably complicated, which is ultimately one that supports bidirectional reflectance distribution functions, which is like a complex way of modeling surfaces. But it's, again, I've picked it intentionally because I know that it's a bit harder than just doing a simple ray tracer, and I wanted to see how it would go with that.
Yeah. Okay.
And as it kicks along, I've got it to update this Claude.md file itself. Okay, we've had this discussion about what I want you to build and the constraints of how I want you to build it. Go and write that down. Let's see if we're aligned on this thing. And it's done reasonably well. Like we have all the core technical decisions here, like it's going to run parallel. We're going to do Monte Carlo integration. This is another one. I pushed it in the direction that I wanted it to be shaped rather than just letting it do whatever, because I thought it would go a long way and then end up being useless. Things that I thought it would get wrong, like the coordinate system will always be shaped this way so that it didn't do strange things where some was one way and some was left-handed. But things that I think matter as kind of foundational decisions for a ray tracer, more or less. And I'm not an expert here, right? If anyone comes and listens and says, this is all madness, maybe it is, but it's served me reasonably well up to now. And from that point on, the kind of the next big thing was like, we had this technical foundation. What are the logical steps to implement it? And because I wanted this to go, as the kids call it, fairly YOLO mode, where you just let it rip for a while and then you come back and say, yeah, it's okay or not. I went with really coarse-grained steps. You'll build the foundational project, you'll build camera abstractions, you'll build a way to load scene files, you'll do integration and so on, and made it write unit tests as it kicked along and looked at the outputs and said, yeah, this looks pretty sensible. And by the time we got down around here, it was actually working quite well. It's not the fastest thing in the world, but it's functional. And if you look at the structure of the code, it's roughly what I've seen as how other people tend to structure simple ray tracers. It's not as horrible as I was expecting, I would say, for something that's quite a chunky code base now.
Do you think it would have gone through that basically its own checklist that would have been similar if left to its own devices?
I'm not sure. I think that it would have confused itself with different implicit decisions at local points. So super concretely, one of the points I made was about the way I wanted it to do the coordinate system, like right-hand coordinate system or whatnot, like x-axis points in this direction. And you have to constantly make decisions based on that over and over again as you go through, more or less. Like when you do different parts of the intersection code and whatnot, you have to have the same thing in mind. I think if you don't spell it out explicitly, it's just going to do something. And some of the time it will line up with the way it's done it somewhere else and some not. So in that case, I think it's important. I don't know how it would divide it up by itself. I've noticed that in Claude now, it often generates itself an intermediate to-do list as it goes through.
Yeah.
and it checks those off as it goes through the steps. But the scope of the whole thing here is so long that I don't know that you would get it to do it all in one prompt. But when I was doing, say, one of these, you would see that it would create a submodel of what it had to do and tick itself off as it went along. That was a very rambly answer. I'm not sure if I answered your question.
Yeah, you got it.
But it's worked pretty well. I'll show you what it output. It's not super spectacular, but it's very functional. I'm going to have to zoom over to another screen and I'm going to lose you. So tell me if you can still see.
Yeah, I see colored
Cool.
browser window. Yeah, okay.
And you can see a Finder window, I hope.
Yep.
Cool. So there's a couple of different scenes it supports.
Okay.
Here's one I showed you earlier, and you said that looks very, very 90s, I think.
Yeah.
But it's, sorry.
Yeah, vintage 90s. I'm trying to think. There was like this, technically it probably was like a ray tracing PC application that became popular.
Like Blender or something, perhaps.
Way before Blender.
Oh, really?
Yeah, I'm thinking back in like the late 90s. I'll have to look it up. But it reminds me of stuff that thing would output.
Yeah, it's interesting because you look at it and you see the noise and you say, oh, it's a bit noisy. But that's what ray trace images tend to look at, because you're always making these decisions about where you should randomly cast the next ray based on when you hit a point. You don't just bounce it straight off and go towards the light or whatnot. There's always some probability it goes in some crazy direction. And that means that to render a scene accurately, you just cast more and more rays and effectively average them together. But because you want it to finish at some point, you put an upper bound on that. And the upshot of that is that they start very noisy and they converge on something. But that noise and the way that the reflection off of the light looks and the kind of shadowing, the soft shadowing from the ground, like it's pretty typical. It's done reasonably well there. We have, what else do I have that's interesting? Of course, we have a teapot. It's important to have a teapot.
Absolutely.
In this case, it's a bit more wild. I'm not really sure what's happening under the teapot on the plane. I think there's some reflection and some occlusion of the lighting, but it's done the teapot loading itself. I've given it an object file and it's passed it and loaded it and everything. And again, it's like approximately what you would expect. And I haven't looked at the code for this. I've just let it rip and judged the output and told it what I would like it to change. We have a very noisy teapot too, but that's not so interesting. And the other thing I did, which I'll point out really quickly while we're here, is make it reflect on its coverage of the own code base to decide where it should be writing tests. And the reason I did that really explicitly is because you've probably seen it as well. They often tend to go off and make crazy adjacent changes to things that you don't ask for. And without good test coverage, you have no idea that's happened. It takes so long to run the renderer to get an image out. You can't always check every output by running the whole thing through. So I want a decent test coverage.
Wow, this is great. I've never seen anybody do this.
Yeah, I try and put as many things in the way of it doing terrible stuff that I don't have to possible, basically.
So do you keep this up like in another part of your screen to just keep an eye on it all the time?
No, I tell it to follow it. So if we go back over here, so whenever you add tests, go and check the coverage again. I haven't told it to do coverage on every build or every change because it takes a while to rerun the coverage because the tests are doing a little bit of rendering in them. But whenever I go through with my version control system and see how much it's touched every time I let it touch something, and if it's touched a lot more than I think it should have, then I say, go check the coverage again, go check the unit test. Have you broken something? And
does it feel, how like everybody forever has been talking about shifting left, and now I feel like we're shifting back to the right. Like the human in the loop part is the other direction we've been trying to tell people to go. And like now we're all the way at the end again.
Yeah, it's definitely, it's such a strange interaction loop doing this stuff, I find. I think there's a big part of shift left in it though, in the sense that you want to use more of these tools that convince you that the thing it's produced isn't bad. So like more static analysis, more tests, more coverage, because ultimately you're trying to use it in a way where you don't have to put too much scrutiny on the code, right? Like you want it to produce, or at least in this case, I just want it to produce heaps of code and to roughly work. And to convince myself that it's roughly working, you can use all these other nice kind of shift lefty tools to try and keep an eye on what's come out without having to review and understand all of the lines of code. To be clear, I think the way I've built this is not the way to build a serious production system, but it's a fun exploration of what you can get away with absolutely no hands on the steering wheel and a bit of enthusiasm and time.
Yeah, and I think what a lot of people are realizing is that with things like the Claude file and even your logs file, but just having a form of context, right? So that we always hear that all these models are best if they know all the context. But if we're upfront about what we want, what the guardrails are, it lets us build a little bit more trust with them, with the models and what they're doing, because they do output higher quality stuff, more complex things like what you've done here. However, as you pointed out, we've all still recognized that they still get to a point where you can't just like YOLO and completely walk away. You do have to check in on it every once in a while, because despite giving it clear instructions, it still seems to run into another problem somewhere where it just can't keep up with that.
Yeah. And often I think so I should preface this by saying I don't know a lot about generative AI. Like, I'm a programmer, my focus is on programming, and I use the tools that come to me. But it seems like they often do things to try and make you happy, even if they don't have confidence that it's good. They always kind of want to take positive action rather than just throwing their hands in the air and saying, I am not sure about that. And in some cases, you get really fun effects of that in the output code. And there's a really common pattern that I've seen a lot with Rust code bases, which I spend a lot of time on lately, which is you have some borrow checking issue. The borrow checker is this famous thing in Rust that makes it so that you don't have to work with malloc style C memory, but you still get fast performance. But every now and again, you get these crazy compiler warnings that are saying you have done the bad thing, fix the bad thing. And often it's not super clear how to fix the bad thing. If you go and let Claude rip on those, sometimes it fixes them. But if it's at the point where you probably couldn't have fixed it yourself because it's a bit convoluted for whatever reason, it will do terrible things to try and make the compiler happy, but almost certainly not what you want. There's like an escape hatch where you can say this memory lives for the entire life cycle of the program, which you almost certainly never want to use. And it'll just grab it all the time and be like, yeah, I put static on it, you're good. And you're like, no, this is not what I want. Please undo that. And I'll actually think about it now. Thank you. But once you start to recognize that and realize in these cases, probably it's not the hammer to reach for, I think it's fine.
Yeah. There's so many times where I've found myself speaking to it like it's a toddler. No, I just told you not to do that.
Yeah. And I get angry with them, and then I feel really strange about it afterwards. I'll put on the caps lock and I'll be like, no, this is wrong. This is not what I said. And then you see it reflecting on what you've said, and it says, the user is emphatically telling me he is not happy with this outcome. I better think again. And you're like, yeah, I feel a bit bad about it now, but yes.
Yeah. I don't know if bullying the AI is the right move, man.
No, I'm on a list now, and so are you probably, but we can just hope the context window isn't too long.
So what's next before we run out of time here and wrap up? What are you going to explore now?
I want to keep pulling on this one because it's cool, and I want to see if I can make it do more complicated things. But I also feel this tension where ultimately I'm just spending a lot of energy on something that's not solving a real business problem. That's a bit awkward.
You're learning.
Sorry.
You're learning about these tools. I think that's the big takeaway for me on a lot of these things, is just staying aware of how these things work to the best I can to be able to have conversations with folks.
Yeah. But I use it much more seriously as well in day-to-day work here. Yesterday, for instance, we have all this data internally in our analytics database, right? I know that you're always hunting for fun fucks in there. I thought I would start learning about that. And I found this GitHub repository that we have that has all the different schemas in it, but there's so many files that GitHub won't even list them all in the UI. It just says there are too many files. So I checked the whole thing out, chucked Claude at it, and I won't share this because I think it's an internal thing, obviously, and made it generate a Claude index for it, and then just started asking questions about the particular data set I was looking for, which in this case was APM related. Like, how can I figure out what services I'm running and how they relate to other services, stuff like that. It's super effective, and that saved me a lot of time. Yeah. Because you guess a little bit like, oh, I probably want to look in this file, and you read the schema a bit, then you compare it to something else, and 2 hours have passed at the end, and you have this really vague model of this tiny corner of this massive code base.
Yeah.
There's no more effective tool than things like Claude for that now. I think that's quite impressive there.
Yeah, once the code base is indexed, it is pretty nice to just be able to find something.
Yeah,
and you look around a lot easier.
And you move beyond like crazy grep expressions where you're like, yeah, it's probably called this or maybe that, just with like all the or characters in the middle, and then you try and decode the rubbish that comes back. I find that really useful. And for more normal code bases, I mean, with this ray tracing thing, I'm being a bit silly, right? But I've actively chosen that direction because I thought it would tell me something interesting about the tools, more or less. But it's indispensable for everyday programming now. There's lots of stuff where it's more than just go and render this template, go and do this basic code generation. There's a bit of nuance to it, but there's not so much nuance to it that it can't be done mechanically. You just traditionally have to go through it yourself. And like an example I had yesterday was I am building a service with James for some stuff for a demo we're building, but it has a database schema, an API schema, some internal models. And you can start with any one of them and with your brain, with very little energy, produce the other ones, but you're probably going to have to go and do a bunch of fiddling in your editor. And Claude and Cursor are ridiculous at that. You just point it at one and say, hey, I want you to go and build the ORM backend for this, use Postgres, use the current Java annotations, write some unit tests. It thinks for 10 minutes, it comes back, you look at it, you're like, that's perfect. Thanks. I was having a coffee while you did that.
Yeah, it's exactly stuff that's we never maybe thought of it as boilerplate, but I know that the way I would manually go do it is there's a set way I'm going to go do it, and it's fine. I know how to do it. I just don't have the time, or I don't want to make the time to do it, even though I know I need it. That's where these tools come in.
Yeah, exactly. It is boilerplate, but it's just like a tiny bit more complicated than just find and replace from a string, and that's enough that the human has to be involved. Otherwise, no more.
Yeah, we don't have to. You can if you enjoy doing it. If you want to make very artisanal Rust code or whatever your favorite flavor of language is. But okay, Scott, I appreciate you showing us your terminal setup with Tmux and Claude Code. And what was the editor that you said?
Helix.
Helix.
I feel like I should have a prepared advertising statement for Helix because I often tell people they should use Helix. But Helix is amazing. Check out Helix.
Okay, cool. Thanks for showing us your setup and walking us through your ray tracing project and some of the other observations that you found as you explored Claude. And let us know if you find anything else as you continue to look around, and love to chat more about it.
No worries. The next time you find another exciting terminal-based tool, feel free to ping me.
I absolutely will. All right. Thank you. And we will see you on the next one.